for the length of this diagonal of the square. One thing to pay attention to is if this is a square, it means that these are not only right angles, but that these two sides are congruent to each other, so this becomes a 45, 45, 90 triangle. To find the area of a square, it is equal to, and I'm going to put an X over here, the side length squared. So to find the side length itself, I'm going to take the square root of 144 to get 12. Now, if this side is 12, I could go through the whole Pythagorean theorem to get D, but if I know my 45, 45, 90 triangle, I know that D is equal to the side length times the square root of 2, and then it said the area was in centimeters squared, so that's just in centimeters. If I forget that, I can sit there if I have to and say, well, 12, I know this is 12, and I could do 12 squared plus 12 squared equals D squared. Oops, that should be a D squared, not a D2. So 144 plus 144 equals D squared. So D squared is the square root of 288, but then I would have to reduce that radical and realize that 144 is a perfect square that goes into 288. Once I simplify this radical, I should get my 12 square roots of 2. So 140 in this case is equal to the leg times the square root of 2. To solve for a, I divide both sides by the square root of 2. And you were allowed to leave radicals in the denominator this year, so a is just 140 over the square root of 2, and my units I don't have. So 140 over the square root of 2, because these two should be congruent to each other. They didn't give me units on this problem, so I don't need to write units in my answer. If you rationalize the denominator here, your answer would be 70 square roots of 2 on both of these.